Hello and welcome to a new section, Port Binding Shells, command prompts that are bound to ports. What is a port binding shell? Let's take a look at this diagram. This is our red server, which is listening on the port 4444. Now on the red server, we will have a CMD command, but normally the CMD command will only be able to run locally on the server itself. That means you will have to sit in front of the machine and open this command prompt and do your work here, type your commands here. But a port binding shell technology allows the command prompt to be remotely accessible. So how that happens is that the command prompt will run invisible on the server. That means nobody knows that it is running. It will not show up any command window on the server itself, but it can run silently, quietly, without opening a window. And it will also be able to listen on port 4444, so that when a client were to connect to this port 4444, the server will give back a command prompt to the client, and the client machine remotely will be able to access the command prompt as though the client was sitting right in front of the server itself. So this technology is called port binding shell. The word shell is referring to the command prompt, and then the port is whatever port you assign, and port binding means that the shell is bound to the port. So this is what is meant by port binding shell. What is the use of a port binding shell? Using a port binding shell, you can remotely access a machine and get a command prompt. You can type any commands at the prompt, and it will be sent to the server to execute. The results will be sent back to the client. It is like sitting in front of the server and typing commands in the command prompt. So whatever you can do in front of a server using a command prompt, you can also now do remotely from a distance, from a different machine, from the internet, with the use of a port binding shell. Let us look into the details of how the process can work, so that we can understand how port binding shell can be implemented. So take for instance here, we have a command cmd.exe. Now every process, including cmd.exe, will have ways for inputting and ways for outputting. So the input to any process is called standard in. So in programming, when you write std in, it is referring to the input to a process. Similarly, every process will have two outputs, the standard out and the standard error. So this is the symbol to refer to standard out, stdout, and this is a symbol to refer to the standard error, standard stderr. Now why do we need to have two? Traditionally, the standard out will display the non-error messages. For example, if you are expecting to perform some calculation and it will output the result, so it will output through this standard out. You can think of all these standard in and standard out as something like pipes. So a pipe allows you to channel some data in, and a pipe also allows you to channel something out from the process. So standard out is a virtual pipe, so it's a standard error. Standard in is also a virtual pipe. So standard out is to output the normal, regular messages. Standard error, on the other hand, is to output the error messages. If there are any errors, it will be output to standard error. However, standard out and standard error both share the same hardware. That means standard in and standard out and standard error, all three share the same hardware. That means all three will be using the command prompt. That means standard in is also from here. This is where you input your commands and it will be channeled to the standard in. And then it will process, and then standard out, standard error also will come back and output to the same command prompt. So this traditionally is how processors can get data, input commands, whatever, and process and output the result using this kind of understanding, this kind of design. So one of the limitation of this is, how are we going to get this command prompt remotely? If this command prompt is only locally, how are we going to make it so that it modify this, hack this in such a way that you can actually intercept all these standard in and standard out and then send it off to a distant terminal somewhere, to a distant machine, to the client somewhere? So let's take a look at the solution. So the solution is to redirect standard in and standard out standard error using pipes. So in programming, operating system concepts, a pipe is where you are trying to link two different processes together. That traditionally is what pipes are all about. So pipes are just a virtual construct. It's an imaginary kind of construct where we create and then link two processes together. So using this concept of pipes, we can also redirect all the standard in and standard out. So in this example here, we have now intercepted our standard out by putting a pipe between the standard out and standard error and the output. Similarly, we are now also inserting another input pipe between the incoming commands and the standard in. So the only thing new here is the output pipe is intercepting all the outputs. The input pipe is intercepting all the inputs. So this is what we mean by redirecting. So all the standard outs and standard errors are now being redirected to an output pipe. And all the standard in is being redirected, is being intercepted by the input pipe. So in this example here, you can see once you are able to intercept all the outputs and input, you can then redirect those outputs and inputs to wherever you want. So in this case, the output pipe will be intercepting all the output from the process and pushing it over the socket to a remote client. In the same way, all the input from the client now will be channeled into the input pipe and redirected to standard in. So whatever the user types on the client here will be sent to the input pipe through a socket, port 4444 or 5555, whatever, and that input pipe will then push it into the standard in. Similarly, whatever commands that has been executed and the result of the commands will now be pushed out into the input pipe, and the input pipe will then handle all the data transfer across the socket, the port, over back to the client. So this is how we can hack the normal input-output flow of a process in order to be able to bind this input-output to a port. Now this is something more detailed. If you look at the output pipe itself, inside the output pipe itself, we need to create something called a command output data handler. So this is just like a kind of a callback function. Callback functions in programming means that a function that is waiting for something to happen, and then when that something happens, it will be triggered. So similarly, when we have a command output data handler, it will be waiting there for the command to process to execute something. So once the process executes something, and sends it to the output pipe. Output pipe will then be able to receive it through the command output data handler. So the command output data handler is part of the output pipe. So this is the design in C#. Right? Both are actually the same thing. The output pipe is also the command output data handler. And then the stream writer is the same stream writer that we saw in all our previous lessons. Stream writer is used to push data into the socket. So this is nothing new here. Stream writer is just the same. Similarly, for the stream reader, the stream reader is responsible for getting the input from the socket. Now the stream reader will be channeling all the data that is read into the input pipe, and the input pipe will then forward it into the standard in. And then the CMD, of course, will remain a hidden process. So now here it is shown as something which is in more detail. We have a port, assuming we are using port 5555, so this will be your network socket. So this part here of this diagram all belongs to the server machine, the server rack. And then all the thing on the right here is a client. So all this happens within the server itself. So this is our new design for our server rack. So in the coming practicals, I'm going to show you how to create this output pipe along with the command output data handler, how to create the input pipe, and also how to use the stream reader and hook it up with the command output data handler, and also how to hook up your stream reader with the input pipe. Okay, so we are going to create output pipes and input pipes and hook all the components together in the upcoming practical walkthroughs. So that's all for this conceptual lecture on how the whole thing works and ties in. I will be seeing you in the next lecture to implement this design. Thank you for watching.